All right, so before we get to actually like drawing chemical equations from scratch or from reading a reaction, let's talk about the parts of a chemical equation. And to do this, I'm just going to look at the combustion of methane or the burning of methane gas. So methane is CH4, and that reacts with oxygen, and it produces carbon dioxide and water. Now let's kind of talk about how this reaction is separated. Everything to the left of the arrow are known as reactants. These are the things that you start with at the beginning of the reaction. You mix these things together and you subject it to some sort of condition, and then they produce products. So everything to the right of the arrow we refer to as products. Now, the reactants and products are separated by a reaction arrow. And sometimes you might see some stuff on this arrow, like above and below it. So things that are above or below the reaction arrow are typically like reaction conditions. So like this triangle here, that means heat. So a lot of energy was supplied. Sometimes below the arrow, you might see solvents or temperature conditions or even time conditions. You might see those around there. Now let's talk about the individual parts. Um, so notice that each part of this equation has a letter in parentheses. Those letters here represent the state of matter that that particular atom or compound or element is in for this reaction. So a letter G means that the element is in the gas phase. A letter S means it's in the solid phase. L means it's in the liquid phase. And sometimes, or actually quite often, you'll see AQ, which stands for aqueous, which just means that substance is dissolved in water. And that's different than the liquid phase. Liquid implies that the substance is pure. It's just in its liquid form. Like water can be in gas, or it could be liquid, or it could be a solid, depending on what state of matter it is for that equation. Now, there's some other things that I haven't referred to quite yet, like these numbers next to some of the elements or atoms. These are referred to as coefficients. These are important values that basically tell you the ratio of those items in that chemical reaction. So if we look at oxygen, for example, that number 2 next to oxygen means that that two molecules, or if you want to get a little bit more expansive, we could say 2 moles of oxygen are reacting. And you'll notice that some of the components of this equation don't have a number next to them, like the CH4 and the CH2. So if there isn't a number next to it, it's assumed to be 1. And those coefficients are very, very important when it comes to chemical equations, because if you just look at the product, I'm sorry, the reactants, that those coefficients basically tell you that for every molecule of CH4, I need 2 molecules of O2 to react. Or again, I'll expand that. For every mole of CH4, I need 2 moles of O2 in order for the reaction to be complete. And what does that mean for the product side? Well, that means if everything is fine on the reactant side, that I will get 1 mole or 1 molecule of carbon dioxide and 2 molecules of water if this reaction is complete. Now, this kind of brings me to one of the most important aspects that we're going to spend a lot of time on um, in the following lectures, and that is that equations. I'm just using an abbreviation here. Equations must be balanced. What I mean by that is that you have the same atoms and same number of atoms on both sides. Because all reactions have to follow the law of conservation of mass. Matter cannot be created or destroyed. It can rearrange, though. So let me take all those coefficients out and just redraw this reaction. Let me show you what I mean here by balancing equations. So I want you to look at the reactant side. On the reactant side, we have 1 carbon atom, 4 hydrogen atoms, and 2 oxygen atoms. I'll just put OX so that's not a 0. So 2 oxygen atoms. On the product side, we have 1 carbon, 2 hydrogens, and 3 oxygen atoms. If we left it like this, we're implying that we're destroying some matter. We're destroying hydrogen atoms and somehow we're making oxygen atoms. This is not a balanced equation. So the way that we balance it is to use coefficients. And I'll discuss that in detail on the in our next lecture. So here's kind of the way that you're going to look at this. We're taking CH4 and 2 molecules of O2. We're going to put them in a beaker or wherever, and we're going to react them together. They're going to bounce into each other and collide. The heat's going to cause a bunch of things to happen. And we're going to get 1 molecule of CO2 and 2 molecules of water. Now, what I want you to do is pause the video. I want you to count the number of atoms on each side. All right, so now that you've done that, let's count them. 1 carbon, 4 hydrogens, 4 oxygens on the left, 1 carbon, 4 hydrogens, and 4 oxygens on the right. This is the importance of ensuring that the reactions are balanced. As I said, we're going to discuss that in the next video on how do we balance a chemical equation.